Now I want to show you the details behind this technique, but one of the nice things about the matrices is even if you don't know the details of a technique, you can still do fine as long as you can catch on to how to create the matrices. Now for our first example, we're going to consider an economy that's made up of agriculture and energy. And notice that the two are interdependent. So we have some of the agriculture people that need some of the energy, and we have some of the energy people that need some of the agriculture. And of course, the reason for having agriculture and energy industries in the first place is so that people in the outside world can also access some of that. Now you'll notice here we're given some of the details about the interdependence of the two industries, and we're also told about the external demand for those. We're going to use X and Y to represent our two industries. Now, what these details are telling us is we have an internal demand for agriculture. If you look at what I've highlighted, you'll notice that each unit of agriculture requires some agriculture to produce it. 30 cents of agriculture is required to produce agriculture. 30 cents of agriculture would be 0.3 times X. Likewise, it says that each dollar's worth of energy produced requires 20 cents of agriculture, which means we need to multiply 20 cents times Y. Same thing, the internal demand for energy would be the 10%, 10 cents, times the amount of agriculture, and the 40 cents times the amount of energy. Now we can write this. We can write this into a system of equations like this. The total demand, that's the X and the Y, is the internal demand, that's the equations that we just came up with, plus the external demand. Now for the external demand, we'll just use a 12 for the 12 million and a 9 for the 9 million and assume that we remember we're talking about millions. Now, like we did in the last section, we can write this as matrices. Now, very much like we did in the last section, we can write our matrix from this just by leaving things in their relative positions and recognizing the matrix multiplication results. So the X and Y just stays X and Y. You might recognize that in the middle, the 0.3x plus 0.2y and the 0.1x plus 0.4y can be written in matrix form, like in the last section. And the 12 and the 9 we'll write as just 12 and 9, but in matrix form. If we relabel these capital X, capital M, and capital D, then we have a matrix equation. Now, since we solved this in the last section, I'll just review it and go through it a little quicker with you. We will subtract the M times X from both sides, use the X as I times X, and factor out the X. Multiply both sides by the inverse of whatever's next to the X, and there's our solution. Now this is on our formula sheet. Now to use this formula, we just take our technology matrix and our demand matrix. We can enter those into our calculator along with the identity matrix. Now since the technology matrix is a 2 by 2, our identity matrix needs to be a 2 by 2. So we'll type that in matrix I. We can't use the M matrix because there's not an M on our calculator. So we'll type that in matrix A, and then we'll type matrix D. After typing those into our calculator, we have to type I minus A, since we're using A instead of M, inverse times D. Okay, that comes out looking like this. Now the neat thing is, top number X, bottom number Y, and there's our answers. Now the bottom line of this is we have that formula on our formula sheet. We need to know how to create the two matrices, the technology matrix and the demand matrix. Now to create the technology matrix, our rows are going to represent inputs and the columns outputs. You cannot mix them up. Now we have to keep things in order. In the problem that we're looking at, we had agriculture and energy. If we have agriculture first, energy second on our rows, we have to have it that way on our columns. The first spot in the matrix is the input from agriculture to produce agriculture. The second spot is the input from agriculture to produce energy, the input of energy to produce agriculture, and the input of energy to produce energy. Here was the statement that we had in the problem that we were just doing. Do you see where it says each dollar's worth of agriculture produced? Identify the spots in the matrix that correspond to agriculture produced. That would be the first column. Which number in that spot represents the agriculture input? That would be the first one. How about the energy input? That would be the second one in the same column. Each dollar's worth of energy produced means the second column. Which one of those numbers corresponds to input from agriculture? That would be the first number. And the 40 cents is the input from energy. Now that's how we create our technology matrix. Now we're going to take a look at this problem without all of the details that I went through on the previous one. What we need is to create the technology matrix, the demand matrix. Enter those into our calculator and use the formula from our formula sheet. Notice we have 3 industries this time. So we have a 3 by 3 matrix this time with the rows labeled agriculture, manufacturing, and fuel, and the columns labeled in the same order. Now here was our first sentence. Production of agriculture is column 1. That requires an input from agriculture, row 1, of 0.3 units. An input from manufacturing of 0.3 units, and an input from fuel of 0.4 units. Now similarly, this is telling us that production of manufactured goods, second column, takes an input from agriculture, first row, of 0.2 units, an input from manufactured goods of 0.2, and an input from fuels of 0.4. And the last sentence tells us the production of fuel, third column, takes an input from agriculture of 0.2, an input from manufacturing of 0.3, and an input from fuels of 0.1. There's our technology matrix. Now, here are a few questions to check your understanding of the technology matrix. How many units of manufactured goods are required to produce 1 unit of fuel? Here's fuel production. Where do we see manufactured goods? Did you pick that number? Now, can you find how many units of fuel are required to produce 1 unit of agriculture? How many units of fuel are required to produce 1 unit of manufactured goods? Now this one is a little more involved. Production of which product is least dependent on the other two? The production of agriculture would be the first column, and it's dependent on manufacturing and fuels, total of 0.7. Manufacturing is the second column. It's dependent on agriculture and fuel, total of 0.6. And production of fuel requires 0.2 from agriculture and 0.3 from manufacturing for a total of 0.5. That would make fuel the least dependent on the other two. Now back to our original problem. We were asked to find the total output to meet the external demand of 9 million agriculture, 11 million manufactured goods, and 15 million fuels. Well, the demand matrix has to be in the same order as the other: agriculture, manufacturing, and fuels. So this is a 3-by-1 matrix with the numbers in the proper order. Now that is how we create our technology matrix and our demand matrix. On the formula sheet, you have the formula that we need to find the total demand. Now, since our technology matrix is 3-by-3, then our identity matrix needs to be 3-by-3. We can either enter that directly, or we can use our calculator to generate it. If you go to the Matrix Math menu, you notice number 5 says Identity. If you choose number 5 and type a 3 after it, you get the 3-by-3 identity matrix. You can then store that using the STO key in Matrix I. Now the matrix names on our calculator don't go up to M, so we have to choose another letter besides M. If we use A, we can go to Matrix A and enter that into our matrix editor. Likewise, we need to enter Matrix D through our matrix editor. Then we simply type the formula like we see on the formula sheet, except of course, instead of M, we need A. And the numbers that we get are in the same order: agriculture, manufacturing, and fuel.